our own Andrew Percy. Dr. Percy is going to be our moderator today, and he is our Senior Applications Chemist for Mass Spectrometry and the Mass Spec Omics Product Line Manager at CIL. And his responsibilities, among many, many other elements, involve technical support, product development and assessment, as well as the writing of CIL marketing literature for a wide variety of areas, including all of our omics platforms. So with that, happy to hand it over to Andrew to take us through this afternoon's session. Thanks, Andrew.
Thank you, Greg. Just a minute here as I share my screen. Hi, everyone, and thank you for joining us today in this MS-focused session of Isotope Day. My brief intro will provide a general overview into the benefits and MS application potential of stable isotope standards and their mixtures. The power of mass spectrometry has grown tremendously over the past few decades. Mass spectrometry has become an incredibly versatile technique with broad analytical detection and deep compound insights. The prowess of mass spectrometry is strengthened by its ability to couple to various separation technologies, as well as its ability to analyze vast sample types. The applications of MS-based methods are broad and certainly expanding, with covering a vast number of areas, including those shown here. The importance of stable isotope standards for MS-based methods cannot be underemphasized. Even in exploratory research, the use of stable isotope standards can still hold merit. Overall, the use of stable isotope standards can help increase identification confidence, enable quantification and flux measurements, help reduce analytical variation, and assist in improving method transferability between labs. The two technical notes I show here, which can be accessed in our clinical MS catalog, documents the importance, benefits, and selection process of stable isotope standards for MS-type applications. The salient review article shown on the right provides a historical account of stable isotopes and mass spectrometry in the life sciences research arena. At CIL, we offer a broad and diverse portfolio of labeled and unlabeled compounds. The total exceeds 15,000, with applications covering a wide spanning array of research areas, a few of which are highlighted here. The 5 ensuing speakers in this session will discuss product-specific applications in the omics and environmental research space. The balance of my general intro presentation will focus on standards and mixes in the MS omics area, specifically proteomics and metabolomics. Methods used in omics are vast and continually improving. Here's a very simplistic overview of a workflow. The nature of the steps in proteomics and metabolomics differ, with certain components being added or removed depending on the type of application. In executing this workflow and analyzing the resultant data, several challenges may arise. Some of these challenges are listed here, pertain to method and system performance, signal assignments, among others. At CIL, we offer a very broad array of individual standards and multi-component mixes to help combat some of these challenges. Despite our rich library, though, there may be some individual standards or mixes that are not available. In those instances, please reach out, as we may have ability to provide that in a way to satisfy your needs. Further to the individuals, the standards in our library are both in their neat and or solution form. For proteomics and metabolomics, I've bucketed our offerings according to subcategory as well as metabolic class, with an example of each shown for quick reference. The applications of these include their use in synthetic starting materials, quantitative standards, flux tracers, metabolic labeling reagents, and chemical tagging reagents. Each of the 5 speakers in this session will showcase such applications in their presentations. To the mixes. We offer a number of these off the shelf, with additional in prep and others in discussion. The mixes and kits are in their neat and our solution form, with the panels of varied compositions and the labeled standards being predominantly 13C and or 15N. Specification guidelines in terms of storage and stability are established for the bulk of the mixes in our portfolio, with their newer mixes in the analysis queue to set up those guidelines. In certain cases, the mixes are accompanied by a product document package. In those cases, they're called kits. That document package includes a user manual. That manual provides details of example methods and applications, while also showcasing some example data, such as that shown below for an example metabolomics product called QS. In that instance, the human analysis urine sample was spiked with combined QS mixes, then analyzed by RPLC MRM. And those are 2 example XICs from that resultant data set. All told, the mixes and kits in our portfolio for both MS Omics and MS screening are detailed in this mixes and kits catalog shown here. The use of these mixes and kits will help reduce development time and cost, enhance data quality, and ultimately inspire result confidence in a wide range array of applications stemming from both quality control through qualification to quantification. Now I'm going to touch upon each one of those elements in the ensuing slides as it pertains to omics. First, quality control. Quality control is an integral aspect of method design. In theory, QC samples should be inserted intermittently throughout batch run sequences to help evaluate performance of methods and or MS-based instrument platforms. And this should be performed routinely. For proteomics and metabolomics, we offer a number of QC kit options. In both cases, the kits contain a number of dry down materials as well as a document package. For proteomics, we offer the Pepticon Plus QC kits, which come in 2 types, one designated to evaluate the method, called the workflow QC, and one geared towards assessing the instrument platform, called the daily QC. These QC kits are platform optimized and CPTAC certified. The product flyer shown here details the kit contents, the optimized platforms, as well as a target panel composition. For metabolomics, we offer 2 versions of QC kits, with one comprising 14 metabolites spread across 2 vials, and the second comprising 18 metabolites spread across 2 vials. The compositions of these 2 QC kit versions differ, which provides flexibility to the end user. It should also be noted that the mixes for these metabolite QC products can be obtained independently, which provides a mix and match type scenario, allowing the user to pick and choose depending on their target preference. Now on to the qualifications. A key aspect in qualifying untargeted MS metabolomic methods is to ensure that the signals that are being assigned arise from true metabolite signals and are not a product of contaminant or an artifact. To help with this process, Dr. Gary Patty and colleagues developed the credentialing approach. In this approach, both a uniform 13C labeled E. coli cell extract and unlabeled E. coli cell extract are utilized. These are to be mixed at two different ratios, such as a 1:1 and 1:2 ratio, as shown in the schematic, prior to LCMS analysis. In the analysis, the isotope spacing and the intensities of the different ratios are evaluated in an automated manner using credentialing R or compound discoverer. Only if the ratios are conserved are the signals deemed to be true, bona fide, and not false, arising from a contaminant or artifact, for instance. These types of credentialing products are ideal for benchmarking untargeted MS metabolomic methods, as well as optimizing parameters. And Gary Patty, later in the session, will discuss the application of this credentialing approach in the first segment on the data reduction session. To help end users apply this routinely, we offer the unlabeled and labeled extracts in kit form, either as neat or solution materials. In addition to the quality control and qualification kits, we also offer a number of quantification mixes and kits for MS Omics. For proteomics, we offer the Peptochrome Plus biomarker assessment kits. These kits are used to screen panels of candidate disease protein biomarkers in human and mouse plasma samples. The largest panel for disease screening is a BAC270, which can screen 270 low to high abundance proteins in human plasma samples. And like the Peptochrome QC kits, I should also point out that these kits are platform optimized and CPTAC certified. And the flyer here details the kit contents, optimized platforms, and the target panel compositions. On the metabolomics side of the ledger, we also offer a number of class and multi-class specific mixes and kits, a few of which are listed here. In one example, a set of 33 organic acids and its smaller subsets are formulated into various dried down mixes. Master mix comprises 33 all in one vial, and then once this is solubilized in, for instance, 1 ml of solvent, equimolar concentration of 250 micromolar results. These can be applied in various applications, a few of which are listed here. For instance, biomarker screening, systems biology investigation, and pathway analysis. And each of these products has its own product-specific flyer, which describes the use and the kit in more detail, as well as different types of applications, not just including quantitation.
1 minute, Andrew.
Perfect timing. So to summarize, CIL specializes in the separation and manufacture of stable isotopes and its compounds. We offer a diverse and expansive collection of standard compounds and its mixes, which should help expedite research toward improved analytical figures of merit. Extensions are ongoing with our existing product portfolio to show the applications in new light, while new standards and mixes are in development as well as in discussion. To access the product flyers I talked about today, as well as additional, please refer to our application pages of our website and our literature library. And I'd like to thank you all for your time and attention. But before I explore any questions, Krista, I would like to remind everyone of the deep lineup we have today. It commences with Dr. Matt Vanderheiden and concludes with Dr. Gary Patty. So I'll stop sharing my screen to allow Matt to set up, and I'll take any questions, Krista.
Excellent. Thanks, Andrew. So we are a little bit behind schedule, but I think that's okay. I do have a quick question. You talked about 13C versus deuterium in some of the mixes. Can you speak a little bit about the benefits of carbon-13 versus a deuterated standard?
Sure thing, Krista. The choice of label is very important in the standard selection process. We have preferenced 13C and 15N over D because of its high chemical and isotopic stability. In addition to that stability, well, that stability ensures that the maintenance is retained on the location of the label. In addition to that, it allows a coelution chromatographically with its unlabeled analog. So with those merits combined, this should provide broad flexibility for end use in both method and application.
Excellent. Thanks so much, Andrew, and thank you for your talk.